Alright, welcome to our YouTube channel. So it's Niaki. So today we are going to have this discussion on the November 2019 paper ordinary level chemistry session. So in this question paper we are going to sharpen your exam skills and also to clear up the tricky concept and also to boost your confidence before the real examination. So let us dive to the first question, right? So if you're doing Zimsec, you need to pay attention to the instructions, right? So for section A, we are required to answer all the questions in the spaces provided. And if you're not doing Zimsec or you're doing Cambridge or any other exam board, what you need to do is to pay attention to data. So here, don't focus on exam boards. What you only need is data to answer these questions, right? So we're given Fig 1.1, which shows the technique used in the chemical analysis. So this is the Fig 1.1 with this burette and then this conical flask and then this tent, right? So we are required to name the technique, right? So this is titration, right? So this is titration. This is titration, right? So we are not here to just cram answers or to memorize papers, but we want to broaden our foundation to understand the fundamentals in chemistry. So we want to broaden the question, the titration question. So titration, it is the method which is widely used in laboratories for testing water purity or to test the acidity of any quantity or any solution within the industries, right? So in this lesson we will cover the basic setup and the key steps and also the indicators and how to calculate the concentrations using standardized solutions, right? So that's what you need to know for titration. So here we're given this sodium hydroxide and then this sulfuric acid, right? And also we are told that 2 to 3 drops of solution Y. So as I've alluded to in my previous sessions, that titration, it is a laboratory method used to determine the concentration of a known solution. So we are determining, so titration, it is a lab method used to determine the concentration. So this is the key term of an unknown solution by reacting it with a solution of known concentration, what we call the standardized solution, right? So that's the general overview of titration, right? So we want to determine the concentration of one solution using a standardized solution. So what is a standardized solution? It is one with a known concentration. Or a standardized solution can also be called a titrant, meaning to say the solution used in titration. And also the one with a known solution can be called an analyte, right? So these are the terms you need to familiarize yourself with. And also for the method of titration, the general overview, first we fill the burette and then measure the volume of the solution of a known concentration, right? And then add a few drops of the indicator. So this is the indicator, this one, solution Y is the indicator, right? So we're required to add a few drops of 2 to 3 concentration, right? And then after adding the indicator, we then slowly add the standardized solution and then stop adding the standardized solution when the indicator changes the color and then record the volume. So this is the general overview of titration. So let me rub on this one, on this definition, right? I want to explain the use of an indicator. So an indicator is defined as a weak acid whose conjugate base is of different color. So it is defined by this equation, right? So this is the weak, the conjugate base, and then this is the weak acid indicator. So the color here is different to the color which is on this conjugate base, right? So this is a reversible reaction, meaning to say it proceeds in either direction. So according to Le Chatelier's principle, which says when a system or a reaction in equilibrium is disturbed, the equilibrium position will shift to oppose the change and try to restore the equilibrium position. So this is say Le Chatelier's principle, right? So when the concentration or the acidity increases, the concentration of the H plus or the protons increases, the equilibrium position will shift to the color, to the backward reaction, to the color of the original indicator, right? So increase in the proton will favor this backward reaction, and then increase or decrease in pH or decrease in concentration of the hydrogen ion will favor this forward reaction. So pH is defined as the measure of hydrogen ion within a solution. That's pH, right? So you need to know the definitions of the terms used in chemistry, right? So you should define each and every term used in chemistry. So that's what we should know for the indicator, the types of indicators. We have phenolphthalein, methyl orange, bromothiamine blue, the litmus, methyl orange, the universal indicator. So for O level, you only need to know phenolphthalein, right? And then we have got methyl orange. And then there is methyl red, but it's not necessary for O level. And we have universal indicator. And then we've got the litmus, right? The litmus paper. So these are enough for your O level chemistry, right? So you need also to know the colors. So for the litmus, we have got blue litmus, which turns red in acid, right? And then red litmus, which turns blue in alkyl or on base, right? So you should also know these two colors. So litmus paper is mainly used when dealing with gaseous phase, right? So you should be able to explain why the litmus paper is first damped, right? First damped. So it is said damp litmus paper, right? So you should be able to explain why the litmus paper is made moist when carrying out the analysis, right? So the litmus paper is made moist so that it can dissolve the gases. So litmus paper, dry litmus paper doesn't create an environment for which the gases will absorb, right? So the gases need to absorb on this medium so that they can be analyzed, right? So the gases absorbed here on this litmus paper in moisture condition. So we need water to dissolve the gases. So when the litmus paper is dry, the gases will not dissolve. So that's the reason why we need the litmus to be damped, right? So the color of phenolphthalein. So phenolphthalein in acid, it is colorless, right? It is colorless. And then in base, it is pink, right? And then we go on to methyl orange, right? So in acid and then in base. So in acid, methyl orange, it is red, right? And then in base, it is yellow, right? And then it is neutral, or neutral, it is orange. So orange, neutral, right? So these are the color changes of the indicators. So you should know the color changes of these indicators. And then I explained why we are going to add a few drops, 2 to 3. So you should be able to explain why we add few drops. This is an acid, so the indicator is in weak acid. So on addition of the drops, it will change the pH of the solution if we add the indicator in excess. So we add few drops to minimize the alteration of the pH of the solution. So this indicator contains the protons. So in addition, we increase the concentration of protons. thereby altering the pH. So we minimize error by adding 2 to 3 drops. So you should know the reason why we add a few drops. And also we need to explain the function of the indicator. So there's what we call the equivalence point and the end point. So endpoint is defined as the point. It is the point during titration. When the indicator changes color, right? Indicator changes color. Are we together? Signaling that the equivalence point is reached. So that's the end point. And then for the equivalence point, it is the exact point in titration where the moles of acid equals to the moles of the base, right? So end point is determined by the indicator, and then equivalence point is determined by the stoichiometrical ratios from the equation, from the chemical equation. So in the lab we see the color change, meaning to say we are going to highlight the end point. We don't highlight the equivalence point from the product. We are not the end point, right? So end point and equivalent point are one and the same thing, meaning to say they are of the same range, right? So the end point is used to determine or to confirm the equivalent point, right? So you should know the difference between the two, that the end point is determined by the indicator, and then this one is determined by the stoichiometric ratios from the equation, right? So I think that's enough for O-level titration, right? So we want to move on to the next part of the question, which says state the role of the solution Y. So solution Y, our solution Y, it is the indicator, right? It is the indicator. And then the function or the explanation to signal the endpoint, right? And then so it signals the endpoint before by changing color, right? So that's the explanation. And then describe a chemical analysis that can be done using this technique. So we've got acid base titration, right, to determine concentration. And then we are on this question which says describe how pure crystals of the salt formed in the flask can be obtained. So the equation of this reaction is sodium hydroxide plus sulfuric acid to give sodium sulfate plus water, with the ionic equation H2 H plus O minus to give water liquid, and then here aqueous, and then here is aqueous. So this is the ionic equation for neutralization. So you should know this equation by heart, right? So in the exams nowadays they are asking you that a certain acid or a certain organic acid or lactic acid or whatever acid reacts with a base. So give us this ionic equation. So this is the ionic equation for each and every neutralization reaction, the reaction between an acid and a base. So you should know this equation by heart, right? So that's the equation which occurs in the conical flask. So we can balance this equation by adding a 2 here, right? So we can also add a 2 here. So this equation is balanced. 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid, right, to give 1 mole sodium sulfate and 2 moles of water. So this is in aqueous, then this is in liquid, this is in aqueous, this is in aqueous state, right? So you should know the state symbols right? So I think we are now moving on to this part which says describe how pure crystals of the salt can be formed. So to form pure crystals, we use the method called crystallization, right? So we use the method of crystallization. So whenever they say tell us how we can obtain pure crystals, always remember the method of crystallization. So the method of crystallization can be defined as the method used to separate a pure solid from a solution, right? So it is the best method to obtain a pure salt or a pure crystals, right? So the first step of crystallization, first step, we dissolve the solid or the salt, right? Solid, and then we dissolve the solid in hot water, right? In hot water to make a saturated solution. So I violated this word with a different color, right? So you should be able to explain why we use hot water instead of cold water. So from the kinetic theory of matter, we understand that the rate of reaction is directly proportional to temperature of the reacting particles. So increase in temperature will increase the rate of the collision, the kinetic energy of the reacting particles. So increase in temperature or using hot water will increase the dissolving of the solution of the solid, right? And then on step number 2, we heat gently, right? So that's the reason, and then that's the step number 2, and then we filter to remove impurities, right? And then on step number 3, we then cool the solution slowly, right? We cool the solution slowly, and then on step number 4, we are going to filter the crystals, right? We are going to filter the crystals to remove our remaining liquid, and then on the last step, step number 5, we are going to dry the crystals by pressing them between the filter papers, right? So filter paper, it is a drying agent, right? Filter papers, or placing them in a warm oven, right? So that's the method of crystallization. So you should know the general overview, like to outline the method of crystallization. On number 2 says define the term atom, and then also define the term isotope. So atom is defined as the smallest particle of an element, right? So this is the simple definition of the term atom, right? And then also isotopes are defined as atoms of the same element with the same number of electrons, same number of protons, but different number of neutrons, right? So this is the general the definition of the term isotope. So different number of neutrons, meaning to say different mass, right? So this is the general definition of the term isotope. So we've got chlorine 35 and then chlorine 37. These are these two isotopes of each other. They have the same number of protons and then same number of electrons, but different mass number. So chlorine is on number 17 of the periodic table, meaning to say for a neutral atom or a neutral atom, the number of protons is equal to the number of electrons, right? So for a neutral atom, the number of protons is equal to the number of electrons. So chlorine has got 17 electrons and then 17 protons. But here 17 electrons and 17 protons, right? So what made this 35, the mass number, differs with this 37, the mass number? So it is the difference in the neutron number. So the number of neutrons differs between these two atoms, right? So isotopes are defined as the atoms of the same element. Here we've got chlorine, and then here we've got chlorine, with the same proton number 1717, same electron number 1717, but different neutron number, which leads to different mass numbers. So you should be able to define and give example, and also you should be able to define the term allotrope, relative molecular mass, relative formula mass, relative isotopic mass, relative atomic mass. You should be able to define this term. You should be able to define also the term mole, concentration, right? So these are terms which can be examined for your general fundamental principles of chemistry, right? And also the term allotrope can be defined as these are atoms of the same element with different arrangement in lattice structure. So these are atoms of the same element but different arrangement, same element but different arrangement in lattice structure, right? So these are allotropes. So for example, we've got graphite and diamond, right? So this is an example for the allotropes, oxygen and ozone, right? So you should be able to explain the difference in the physical properties for both graphite and diamond. So graphite can conduct electricity parallel to the layers, but diamond doesn't conduct electricity. Why? Because all the electrons are used in the bonding. And then here for graphite, there is a single electron from the p orbital which is left for the transmission of the electric current. Should be able to explain why this can be used as a lubricant and this one can not be used as a lubricant. So you should be able to explain the uses of graphite. So we have a video on that, explaining the difference in the uses of graphite and diamond on the states of matter. So here we are not explaining, we are not dwelling much on that. So we want to move on to the table. So we've got this table showing the number of protons and then the number of neutrons and then the species here. So we've got magnesium ion Mg2 plus, and then the nitrite ion N3 minus, and then sulfur atom. So as I've alluded to that, for a neutral atom, the number of protons is equal to the number of electrons. So number of protons, number of electrons, so 16. So here we've got 16. And then magnesium is a group 2 metal in period 3 with the proton number 12. So it loses 2 electrons, 2 valence electrons to form the magnesium ion. So we are subtracting 2 from this 12, the proton number, to have 10. And then nitrogen is in group 5, period 2 element. So it has got 7 protons, meaning to say when it is neutral, the number of protons is equal to the number of electrons. So for a neutral atom, we've got 7, but it forms an anion, meaning to say it gains 3 extra electrons to complete the electronic configuration that of a noble gas. So it's 7 plus 3 to give us 10, right? So this is for this table. So you should be able to explain the subatomic particles using this graph. So you should also know this table, right? The subatomic particle. So you've got the particle, the mass, and then the charge. So we've got a proton with a mass of 1 unit with a charge of +1, and then electron with a mass of 1 over 1840 with a charge of -1, and then neutron with a mass of 1 unit and a charge. It doesn't have any charge. So neutrons doesn't have any charge. You should know that, right? So this table is oftenly examined. So you should know this table by heart, and also know the deflection table. So let's say we've got these 2 electrodes. this one the positive, this one the negative, and then we have this spectrum, right? So and then here, so here we've got electrons, and then here protons, and then here neutrons. So neutrons are not deflected within the electric field. Why? Because they are neutral. And then electrons are attracted to the positive electrode. Why? Because they are negatively charged. So unlike charges attracts, and then unlike charges repel. So electrons are deflected first. So you should also take note that electrons are deflected first, right, before protons. Why? Because they are lighter. They've got the mass 1/1840 units, the mass of a proton, which is very, very negligible, right? And also protons are deflected to the negative electrode. Opposite charges attract, right? So in the magnetic field, so this is for the electric field. So for the magnetic field, this is the neutrons, and then the electrons are deflected first. We've got electrons here, and then the protons are deflected to the opposite side, right? So protons. So you should take note that electrons are first deflected. Why? Because they are lighter, and then protons are deflected to the opposite side of that of electrons, right? And then neutrons remain undeflected, right? So we are done with the subatomic particles. So that is what you only need to know for the exams under subatomic particles, right? And also to know the location. Protons and neutrons are located in the nucleus, and then electrons are located in the shells, right? And then you should be able to write the electronic configurations to show the arrangement of electrons in their electronic shells, right? So we want to draw. So this question number 6 says draw the dot and cross diagram to show the bonding in magnesium nitride. So it's magnesium nitride. So we've got 3 magnesium atoms which donates electrons to 2 nitrogen atoms. So magnesium reacts by donating, by losing electrons in the outermost shell to form the magnesium 2+ ion, right? So this is the magnesium, right? So it's Mg, and then Mg, and then Mg, and then for nitrogen we have 2. So this is the nitrogen. So the nitrogen atom should be smaller than the magnesium. You also need to take note on that one. So this is the nitrogen, and then this is the nitrogen. So we have got the electronic configuration of magnesium is 2, 8, 2, and then 2, 5, right? So magnesium reacts by losing the outer 2 electrons to achieve this stable noble gas electronic configuration, and then nitrogen reacts by gaining the 3 electrons to have 8 to attain the octet rule, right? So we have 2 electrons in the outermost shell for magnesium, and then 2 here, and then 2 here, and then 2 here, and then 2 here. And then for nitrogen we've got 1, 2, 3, 4, and then 5, right? This is the 5 here, and then 1, 2, 3, 4, and then 5. So the electrons are transferred from. So a question arises which says, why is it not energetically feasible for magnesium to gain extra 6 electrons? So if you add 6 electrons, you have 8 here, right? So why is it not energetically feasible for that reaction to occur? So it is not it is energetically expensive for magnesium to gain extra 6 electrons than to lose these 2 valence electrons, right? And also it is not energetically cheaper for nitrogen to lose all the 5 electrons than to gain extra 3 electrons, right? And also you should know the effect of a nuclear charge, right, which draws electrons. And also that's not necessary for O level, right? So I want to show you the bonding. So these 2 electrons, the one goes here, and then we have got 6 now. We need extra 2, so the other one goes here. And then we have 7 now, and then the other one goes here, right? And then this one goes there, and then this one goes here, and then this one pairs with this one. So we are done. So this diagram is to illustrate to you the bonding which occurs between the two atoms, right? So to answer this question, we now use the square diagrams. So to write the square diagrams, so this one, and then this one. So this one is for nitrogen. So I'm only drawing the valence electrons, right? And then this one is for magnesium. So magnesium is got the charge 2+, then this one 3-. And then we have got 3 magnesiums and then 2 nitrogen atoms. So 2, 2, 2, 2, 2. That's the valence shell of magnesium. And then the valence shell of nitrogen, we've got extra 3 electrons from magnesium. So we need to highlight that. So we've got we use the dot to illustrate the electrons for nitrogen. So 2 here, 2 here, 2 here, 2 here, and then so we've got 1, 2, 3, 4, 5. So we want to put the cross for the electrons of magnesium. So X, then X, X here. So we want to write the key X electron from magnesium, and then dot electron from nitrogen. So you should also include the key on your answer, and then we are done on this question. So we are now moving on to number 3.